Okay, hello everyone. My name's John Fossbender. I'm admin to the Charting Companion Users Group on Facebook, and with us is Pierre Clothier, sorry,
Okay, that's good.
from Progeny Genealogy, creator of Charting Companion, and we're going to be covering some of the new features in Charting Companion 8, and then afterwards we'll be open for any questions concerning Charting Companion. So.
Okay. Thanks very much, John, for organizing this. Let me just share my screen there. Can you see this?
Yes.
Okay. Okay, so I guess it's just John and Lou and me. Are you there, Lou?
Yes.
Okay, welcome. Very happy to present this to you this morning. So structured query language, SQL means structured query language, and it's sort of a universal language for storing and processing information in a relational database. So I'm going to talk a little bit about databases before going into the SQL. As you probably know, every genealogy program stores its data in a database. For example, Personal Ancestral File, which is one of the granddaddy of genealogy programs, came out in the 80s. They use their own proprietary database technology, mainly because there was no relational database software available in the 80s when they came out. And Ancestral Quest is based on PATH, so they use the same proprietary database. Legacy uses Microsoft Access as a data format. Roots Magic, originally they used something called Codebase, which was an X-base Foxborough clone, but they switched to SQLite a few years ago with Roots Magic 6. SQLite is a very popular open source, free, very fast, very simple database program. Family Tree Maker, the original version, pre-2008, used something called object linking and embedding compound document. After that, they switched to VistaDB, and then when Makiv took it over, they switched to SQLite as well. So Charting Companion was designed to read the database directly for maximum convenience. Linda, thanks for joining us. I just started explaining databases. So Charting Companion reads all the databases directly, whether it's PATH or Access or SQLite. Also, when importing a GEDCOMP file, Charting Companion will create an SQLite database. It's true in all cases except the new Family Tree Maker. The Family Tree Maker, the SQLite database, is encrypted, and Makiv doesn't share the key. So Charting Companion has to go through Family Tree Maker, the plugin API, in order to access the database. And that's unfortunate because it prevents us from doing certain things. So I'm going to now I have a link on my website, and I'm going to paste that right now in the chat part, and you can go there, and John has a poll going on. Let's see, how do I get the I'm trying to see where I can get to the chat. It does this to me all the time. It kind of disappears.
You might have to click on the more with the 3 dots, possibly.
Yeah.
When you share the screen, it hides things.
Yeah, that's right. It hides things. I got this yesterday. That's strange. Oh, I see. Okay. You got to hover over the green bar. Okay, got it. Okay, so I'm posting a link in the chat, which takes you to this web page, following web page, this one right here. And you can click on the third link there. It says voting form. If you click here, you can go to John's poll or voting form, look for enhancement 2365, and that is a proposition to allow third-party programs to access the the Family Tree Maker SQLite database directly without going through the API. And this would enable us, okay, so what I'm about to explain is also covered in the 5 links at the bottom on our blog. If you go to our Charting Companion blog, or Charting Companion or Progeny website, click on the blog. We have 5 posts there that explain the SQL. And I want to emphasize that what I'm about to explain this morning, the SQL programming, it only works if you import a GEDCON into a Progeny's Charting Companion's own SQLite format. So even though a lot of these programs use SQLite, the internal design is very different from one to the other. It's called a schema. So these commands only work with Charting Companion's database schema, which is created when you import a GEDCON. If, on the other hand, the Family Tree Maker SQLite file were accessible to Charting Companion, we could do SQLite directly on the FTM. We could do SQL queries directly on the FTM SQLite database. So I urge you to vote that, and maybe we can persuade Makiv to open up things up a little bit. Okay, so the Charting Companion, in order to use SQL, you have to understand Charting Companion's database design. And there are 7 tables in the Charting Companion database. It's persons, places, events, images, notes, citations, and authors. So looking at the persons table, the persons table contains a number of fields. One of them is called the PIN, and it's simply the person identification number. It's a unique number assigned to every person. Of course, a person contains a name, and the name has 6 parts. There's the name prefix, Mr., Mrs., Doctor, and so on. There's the given name, middle name, surname, prefix, von, de, la, surname, and name suffix, Junior, Esquire. All that is in the same name field. There is a field for the PIN of the biological father and a PIN of the biological mother, the sex, of course, and a few other things. That's the person table, very simple. We have another table called places. Every place is assigned a unique place number, which uniquely identifies the place. Then, of course, there's the place name. And this place table is used for more than just places. It can also be used for storing the name of the source, the title of a book or something. And that is determined by the place type. The places table has a place type which can cover multiple different uses. It can also be used to store an address, the name of a repository, like an archive or a library, the name of a publisher, the title of a book, user-defined event description, or the text of an irregular date, and a few other things. And the third most important table is the events, and it contains the events or facts pertaining to a person. And it contains the PIN of the person to whom these events or facts are assigned or attributed. It contains an event type. There's a long list of different types of events like births, marriage, christening. I'll show you a list at the end. Then there's a field called EV-SECNO, which is either a unique sequence number within a person. If the dual key field is 0, it's the sequence number within a person. If dual key is a 1, then EV-SECNO is the PIN of the other person in the relationship, whether it's a marriage, a divorce, or whatever. There's a date, an event date, and pretty much, and of course, a link to the place where the event took place. And the others are for citations. I won't go into them right now. So here are the different event types. 1 is birth, 2 is marriage, 3 is death, and so on. These are useful if you're searching for certain types of events. Okay, so that's a quick overview of the database, the schema. And it's included, it's described in our blog. You can go there and check it out anytime. So I'm going to come up with a few examples it's always easier to understand by example. So remember, you have to do a GEDCOM import to use the SQL. And the way you access it is find SQL query. And that brings up a screen with the top part is your query and the bottom part's the results. So let's try something really simple. We're going to look for a person whose PIN is 1. So every SQL query starts with select, followed by the names of the fields that you want. PIN and name. And PIN and name, that comes from the table right there, PIN and name. You just copy the information in the documented in the blog. So first, there's a select clause where you specify which fields you want. Second, there's a from clause where you specify which table you want to pull the data from. Again, persons comes from this name right here, persons. And then optionally, you have a condition. So let's take that condition away for a second. That's a very simple statement to select PIN and name from persons. What you do is once you've copied and pasted your query, you click on the execute button. And Charting Companion passes the query onto the SQLite engine, which executes the search. And when it's done, it fills the bottom pane with the results of the query. There you go. These are everybody in the database with the name and the PIN. Pretty slick. That's a lot of information. Now, if I add a where clause, that's a condition. And the where means I want the PIN and the name from persons only for the person whose PIN is equal to 1. So if I execute that, bang, that's the person whose PIN is 1. Let me try 10, 100, and so on. So once you've done that, you can copy the results of a search, okay? So I'm redoing my select PIN name from persons, which has a lot of queries. And what I can do then is if I click, once it's filled, if I click on the clipboard button, it copies the results to the clipboard. I can then, for example, I can then bring up a spreadsheet and I can just paste, click on, paste the results. And bingo. Here's a spreadsheet with all 4,000 names and the pins. Isn't that slick? Another way of doing this is I can click on the save button and it'll save it either as a CSV, a comma separated value, or a genuine spreadsheet. I can save it as a spreadsheet. Test.xls. Click on that. And then I can go to my spreadsheet program, Excel. Say file, open this. And there are the results. So you can do it either way, clipboard or through the spreadsheet. Very convenient. Okay, are we okay so far? By the way, I apologize. This is a little bit intense. The whole point of this, the purpose of the SQL, it's designed so that you don't necessarily have to become an SQL expert. What you can do is go to the blog post, and we have dozens and dozens of examples here. And if you can find something that suits your needs, something that meets your requirements, that satisfies your curiosity, you simply copy and paste it and edit it or modify the SQL query for your particular purpose. These are just examples. The best way to learn is just to copy and paste the examples and then change the data. So here's and one where we look for all the men. So we're going to select a name from persons where sex equals 1. Sex of 1 is men, sex of 2 is women. So I'm going to execute that. And there are 4,200 men. So there's all the males in the database. If I were to switch that to 2, I'd get the women. There you go. These are all the women in the database. Pretty slick. And all these results you can save, copy to the clipboard or save to a spreadsheet. So just all you got to do is recognize the familiar format of the SQL query, a select clause, select fields from a table, and with an optional condition. Stop me if you have any questions. So here's another kind of a query, and this one uses a new verb, the like clause. So again, we have select pin name from persons where name, and the word like here it means it's a wildcard. If you're familiar with wildcards, it means we want every name that contains, and then we have a noun in quote or a word in quote. The percent sign here means wildcard. So we're looking for names that contain something, the word Jones followed by something, okay? So that's find all the people whose name contain the word Jones somewhere. So we click on execute and bingo. Look at that. There are 3 people in my database that whose name contains the word Jones. Okay. We could look for all the Margarets. 33 results. Isn't that fast? Interesting, isn't it? Indeed. Are we good with this? All right. Now, you can combine conditions. So we're going to look here. We have an example where we're looking, by the way, you can break these up at the multiple lines. Again, we're looking for pin and name from persons where the name contains the word Moss, which is a more common surname in my family. And there's the word and here, sex equals 1. So this is all the men whose name contains Moss. So if you execute that, bang, 72 results. Isn't that slick? Fun. All right. If you wanted to find all the women, you would just say for a name like Moss and sex equals 2, 44 results. Interesting. Okay. So you can have compound conditions. All right. So here we have a where clause, and then we open a parenthesis here. And we have 3 conditions. So it says name like Cloutier, or you have the or condition. Name like Cloutier with the letter H after the T. Or name like Cloutier spelt with an S the old-fashioned way. Close the parenthesis and sex equals 1. So if you're a little bit familiar with Boolean logic, this condition will be true if either one of these 3 conditions is true, and sex equals 1. So if you execute that, 113 results, and there you see there's Cloutier with an S, Cloutier with an H, and Cloutier without the H or the S. So you can mix and match conditions. Just remember the and has precedence over the or, so you need a parenthesis to group these 3. Think of the or like addition and the and like multiplication. All right. Now, here's another one. We're looking for births between 1940 and 1950. All right. So again, select pin, events from date. Now here we have a table qualifier, events period, says it's from the events table. We're selecting from the events table where the events type equals 1. This is a birth. And the events type is greater than or equal to 19400000. Now, I didn't mention dates are stored in the format year, 2-digit month, 2-digit day. And the month and the day could be 0 if they're unknown. So any event occurring in 1940 would be greater than or equal to 19400000. And also, we want them to be less than or equal to 1950 and month 12, day 31. So these are all the births in that range. So we execute that. There are 43 results. Isn't that interesting? And these are all the results. Interesting. See how that works? There's, again, you know, if you're confused at first, just copy the examples. Now, we're going to go one step further. We're going to do the same thing, but we want to show the names of the people. This is where it starts getting interesting here. So we're using 2 tables. We're combining 2 tables together. Here we still say pin events from date from the events table. Then there's a second select clause, which we have to delineate with a parenthesis. And here we're saying select persons.name from persons. This top clause here is pulled from the events table. And the second select is pulled from the persons table from persons. And here the condition we have is the pin of the persons equals the pin of the events. So what we're doing is we're matching the persons table to the events table on pin. We want all the records where the 2 match. And the as verb here says we're assigning a shortcut of name to this field. And the where clause is the same, events type is 1, and birth date is in that range. So let's see what happens when we execute that. And here are the results, same results, with the name. So this is the first example where we're combining 2 tables into 1. Very powerful. Again, don't worry if you don't understand the details. It's one of those things where you just got to do it. You just have to do it over and over again in order to become familiar with it. All right. Okay, so now the query we just executed here was a birth with a person's name. Now we're going to get fancier, and we're going to include not only the person's name, but also the name of the place where they were born. Okay. And what we've got here is the select clause, where we want the person's name, the event date, and the name of the place from the places table. And we do something called a join. We join 2 tables. So what we're creating is a subset. We want to combine a table of events and persons that match on the pin. And we're also joining with places. If you remember in the events table, there was a field called place number binary. We want the place number in the events to match the place number in the places on the places table. So we're grabbing events from the events table, names from the persons table and place names from the places table with the same condition. And there you go. We have person name and the place name. Again, don't worry about the details. It is admittedly rather complex, but if you adapt it, for example, you could change the date range. And this would work for you without having to understand the details. Okay, that's pretty advanced. Congratulations for making it so far. Here's another one. Finding, and all these are all designed to help you extract custom reports of your database so you can use it to clean up or fix some gaps in your database. Here's a query that helps you find all the people with unknown parents. So remember the person's the persons table contains the PIN of the father here and the PIN of the mother. Okay. So we're looking for, if the PIN is 0, it means it's unknown. So we're looking for all the people whose father PIN is 0 and mother PIN equals 0. These will be people with unknown parents. So we execute that. And there you go, 1,900 of them. So this could be used. Again, you can save it, print it off, and then go back to your family tree maker database and start looking at these people. Many of them, of course, are brick walls. We'll never know the parents, but there might be others that the information is available. You just forgot to add it. Okay. Now, here's an interesting one. Find all the people born on a certain date. Now, here we're doing the same, so like person's name, events from date, from events, with the join clause here, where we're combining persons and events on a match on pins. Now, this is a little bit of math légère domaine here. Remember the dates are stored as year, month, date. Now, this here, the percent here, it means the modulus arithmetic. It's not a wild card like in between the quotes. The percent sign means the remainder after being divided by a number. So if you take the date and you divide by 10,000, the remainder is the month and the day. If you take that and divide by 100, that's integer arithmetic. It doesn't do fractions or floating point, and you wind up with a month. So this is the month 7 July. So don't worry if you don't understand that, just copy it verbatim. So this expression here extracts the month. And this expression here takes the date, divide by 100, the remainder is the day of the date. So here we have a month equals 7, a day equals 4, and an event type of 1, which is a birth. And that gives you 3 people that were born on the 4th of July. Interestingly, I don't have anybody that died or married or died on the 4th of July. How curious. What are the odds? So you can just don't worry about the math, just change the numeric month and the numeric day, and you can find that will suit your purposes. Okay, now there's another SQL reserved word or verb called count. Instead of displaying, what you can do is you can count all the men. So if we say select count from persons where sex equals 1, that's going to give us a count of 2,232 men. So the count asterisk means count everybody. And we can count the women, and we get 2,207. So you can use that if you just want to count. Let's say you want to find all the people with no sex specified. So remember, 1 is male, 2 is female. So anything less than 1 or greater than 2 would be an error. So if you execute that, there's 70 people with unknown sex. And you might go in there and say, well, that's obviously a woman, that's a man, and so on. You can go in there again, save this list, print it, and you can go in and, so it's useful ways of fine-tuning and perfecting the data. Stop me if you have any questions. Here's a useful one. Find all the people whose birth were born in a certain place. So here we have the usual: select pin, person name for persons, place name for places, and so on. And the where clause here says event type equals 1, which is a birth, and the place name like the word Sydney. So if the word Sydney occurs anywhere in the place name, that'll satisfy the match. So if I execute that, I have 19 results. This is Sydney in the province of Nova Scotia, not Australia. And of course, in your case, you could substitute anything you want pertaining to your genealogy. Here, whoops. I'm going to put the state of Connecticut. So I've got 166 people born in Connecticut. That's my wife's family comes from New England. Her ancestors go all the way back to New England, so that's why there's a lot of Connecticut here. I could put New York. You see how you can adapt it to your needs. 14 people. Oh, look at that. I look for NY. Germany ends in NY, so that satisfied the match. So it gives you, and what's going on here? Oh, Barony, NY. So I'm getting a lot more than I bargained for here. And in fact, there's no New York. Oh, yeah, there's 2 there. So what you can do is just spell it out. That's better. One of my ancestors fought in the American War of Independence on the right side, of course, on the American side, and actually got a pension from the American government. So there you go. You can see how you can adapt it to your needs. Here's a more complicated one. It's to pull up all people and their parents. And the way it works here is, if you remember, there's a father pin and mother pin field in the person's table. So what we're doing here is we're saying we are, and this is interesting, this is called an alias. We are assigning an alias to the person's table. And we're giving it an alias P and also P2. The P alias matches actually we're giving it 3 aliases. Persons as P1. That's the father. So P is the person, P1's the father, P2 is the mother. So what we're doing is we're taking the father pin field, matching it to, we're going to the pin of the father, the mother pin to the pin of the mother, and we're pulling this up. Anyway, and there we go. And there's an order clause here. We're sorting by name. So here you have a list of everybody and their parents, which is pretty cool. You can copy that to the clipboard. Go to your spreadsheet, paste it, and there you go. There's a complete list of everybody and their parents. Interesting. All right. That's a little bit of voodoo there. You can display all couples. These are, by the way, all of these are in the blog post. So the way this works is we are we are aliasing persons with P1 and P2. And we're saying, go to the events table, pull up all the events for every person. And the condition where we want is, remember this dual key field? Dual key is 1, meaning that the sequence number is equal to the pin of the second person. So we're saying, pull up all the events where the sequence number of the event is equal to the pin of the second person. Okay, that's it. Just take it on faith. We're pulling up all the marriages, divorces, engagements, and so on. And here we are. This is a list of all the couples in the database. So like I say, you don't have to worry about the details. You can just copy and paste it verbatim, and it'll satisfy your needs. Again, you can copy it to the clipboard, go to paste it, and there you go. Easy as that. And by the way, if there's a particular query that you are interested in, that you want to execute, and you can't figure out how to compose it, then I would urge you to go to the Facebook Charting Companion user group and post your question there. And either myself or someone can see if we can create an SQL query that will fulfill your requirement. Or you can contact us on our website on the Contact Us page. Click on Customer Support, Contact Us, send me a message, and I will attempt to put together a query to do what you're looking for. We did this recently for a customer who wanted something very sophisticated. He wanted events with no citations, or a list of all the events citing the same source or something. That worked out pretty good. Here's an interesting one. All daughters with a different surname than father. Okay. So the reason for that is that it might indicate that a woman was entered under her married name, not her maiden name. So what we're doing here is we're creating 2 aliases for persons, P2 and P1. And then we're saying, pull up all the surnames from the persons table where the pin is equal to the father pin. We're pulling that out of surname 2. And here's the surname is a special field that contains just the surname of the person. And we're saying where sex equals 2, we only want the women. And where the surname of the father is different from the surname of the daughter. Okay, so execute that. Now, a lot of them are legitimate. They're just misspellings back in the, oh, here's interesting. This is suspicious. But you can see this is suspicious too. But this is a typo. You might want to fix that. Most of them are, misspellings from being illiterate. But some of them are definitely errors. Here, this one. Yeah. This is interesting. Actually, this one, she was adopted. So this is a legitimate mismatch. So this is an error. So I went and entered that incorrectly. You can have a lot of fun with that. Just for fun, let's see if there are men who mismatch. Wow. These are just typical misspellings. I don't know. Is there a name for that, John? Misspellings due to illiteracy or the old days?
Yeah, well, yeah, it's just as names have morphed over the years, and
Yeah,
but yeah, it's like there's one,
you can see
two,
that's
and well, like
obviously
that Zach Bennett Jr., you got somehow Jr. as the
okay.
surname and not,
Yeah,
so that's an error.
that is an error. His surname is incorrectly parsed as Junior.
Yeah.
So that's
Okay.
I gotta fix that. Anyway, you get the idea.
Yeah.
Pretty cool.
But yeah, it's
Oh,
shocking how many of your ancestors were illiterate, and
yeah, oh yeah,
so by the time they did, it's like, well, this is just the way it's always been spelled. So
yeah, that's right. Now here's an interesting one. Lifespans. Calculate lifespans. So what we're doing here is some math. So we're pulling up, so we're aliasing events once. Events as E1, events as E2. And what we're doing here is we're saying E2 matches the pin. We want event type 3, which is death. So E2 is the death. And E1 is event type 1, which is the birth. So we got all these conditions. We want all the births, all the deaths, only if the date is non-zero. Okay. So we gather up all these people, and what we do is we take E2, we take the date of the death minus the date of the birth, divided by 10,000, because it's an 8-digit field. That'll give us just a year. And we do this calculation, and we gave it the alias lifespan. Okay. So watch what happens when we execute that. That's a complicated one. Not for the, there we go. So here is, whoops. Here is birth date, death date, the name. Now, sorted by lifespan. So here we have a lot of, tragic children born at, so it's ordered by lifespan. And look at this, we have a lifespan of minus 1,679 years. Well, obviously there's a mistake here. Her death date is just a month, January. So if possible, that should go in, if I could figure out the death date, that should go in there. Here is another error, -8. He died 8 years before he was born. That's a mistake. Here's another one, died 7 years before he was born. So I got to do some work here. -3, -2, -1. Now, I would never suggest that your data has errors like that, but you get the idea. And then followed by children born at birth. And then it goes in increasing date, lifespan. And down here is at the other extreme end. These may be true, but you may want to double check those. Not a lot of people lived to 107 years in the 17th century, so you want to check that. And you can also use it to do some analysis, distribution of lifespans. You can use some of Excel's more sophisticated functions to do a mean and a median and so on, all sorts of analysis. Okay, we'll do one more. This is looking for all the burials in Connecticut. This can be handy. Say you're getting set to go on a trip, and you want to visit the cemetery, and you want to pull up all the people whose graves is in that particular area. So here we alias persons as P, and we alias events as E, and we want to pull up all the events and that match persons on the pin. And we also want to pull up the places. We want the place number to match of the place match place number B of the event. Call that place. And here is the kicker here. Place contains CT for Connecticut. Remember, the percent here stands for the wild card. Execute that. And here are all the people whose grave lies in Connecticut. Now, of course, that's pretty big search area. So you can refine this. You could say, I want all the people buried in Lyme, Connecticut. And it narrows it down like that. It's a nice list. You can print, take with you, and then visit and the graveyard. All right. Well, it's a pretty intense presentation. Thank you for sticking with us to the end, Linda. If there are any questions, send them to me at or John, send them to me at Contact Us. I'll be glad to address them. All right. That's pretty intense for a Sunday morning. What do you think, Linda? Is this something you could use?
Well, it was interesting. I think I managed to follow it. I have used SQLs in the past with, office work.
Oh, good.
So, hopefully once I get, I've only just bought the charting companion, so I haven't actually used it yet. So, at least I can have a play with it now. Thank you.
Great. Where are you located, Linda?
In Leeds, Yorkshire, in England.
In England.
Yeah.
Splendid. We are honored to make your acquaintance. It is pretty intense. And it's one of those things that I did it just for the fun of it. But, with this, we have many, many examples, and you can, pull them up and adapt them for your need and improvise. And you can't break anything, by the way. This is strictly read-only. You can do no harm. You can just experiment and putz about and never worried about breaking anything.
Okay.
Now, are you using Family Tree Maker, or what genealogy program are you using?
Family Tree Maker.
Yeah.
I do all my work in that. Anything that I have in Ancestry, I actually put into Family Tree Maker by hand. I don't transfer anything over, but I do transfer from Family Tree Maker into Ancestry because I've done my DNA. But I'm still working on that.
Okay, Linda. So if Makiv ever allows us to read their SQLite database directly, you could do all these queries directly from within on Family Tree Maker. You wouldn't have to go through the jet prompt. So if you would kindly take a moment to go and vote there, that'll just increase our leverage with Makiv.
Okay, thank you.
All righty.
Right.
Pleasure meeting you, Linda. Thank you very much for your time.
Okay, thank you.
Okay. All right.
Yeah.
Bye.
Bye-bye.
Yeah,
So,
bye.
John, if you choose